Today we're going to be looking at basic matrix operations. First of all, a matrix is a rectangular arrangement of numbers into rows and columns. We set it up looking like this. You'll have some numbers in it. So if we have 2, 3, 5, 7, they're arranged into rows and columns. We list the dimensions of it in rows by columns. So whenever we talk about the dimension, that's the number of rows by the number of columns. So in this situation, we have 2 rows. We also have 2 columns. So this would be a 2 by 2 matrix. The numbers inside your matrix are called elements. They're the elements of the matrix. Getting back to our dimensions, if we do another one, so if we did 2, 3, negative 3, 0, 1, 5. If we look at this matrix, we have 3 rows and 2 columns. So this would be a 3 by 2. Matrix. So those are that's the basic idea of what a matrix is. We can do a whole bunch of things with that. So if we look at some matrix operations, okay, these are basic operations like we do with numbers. Some of the rules are a little bit different with a matrix. So if we look at adding and subtracting, okay, we are going to add or subtract the corresponding elements. So that means we're going to be adding and subtracting things from each matrix that are in the same place. So if it's in the top left corner of the first matrix, we'll add that to whatever the element in the top left corner of the second matrix. With that, when you add and subtract matrices, they must be the same dimensions. Because we're adding and subtracting corresponding elements, if they're not the same dimension, then you won't be able to add what's corresponding. So if we had 2, 3, 5, 1 plus 3, negative 4, 0, 6, we're going to add those together. This is a 2 by 2 matrix. This is also a 2 by 2 matrix. So we are okay to add them. When we add them together, we'll get another 2 by 2 matrix. So if we add the corresponding elements, my corresponding elements would be 2 and 3, which would give me 5, 3 and negative 4, which would give me negative 1, 5 and 0, which would give me 5, and 1 and 6, which would give me 7. Same idea applies if we go with subtraction. So here I'm going to give you a, let's say, 2, 3, 4, 0, negative 1, negative 3, minus 5, 2, 1, let's say 10, 0, negative 2. Okay, so if we look at this first matrix, this is a 2 rows by 3 columns, so this would be a 2 by 3. This one is also 2 rows by 3 columns, so it's another 2 by 3. So when we subtract the elements, we'd have 2 minus 5, which would be negative 3. We'd then have 3 minus 2, which would be negative 1. We would have 4 minus 1, which is 3. 0 minus 10, which would be negative 10. We have negative 1 minus 0, which is negative 1. And negative 3 minus negative 2, that minus negative 2 is the same thing as adding 2, which would be negative 1. So my answer matrix would be negative 3, negative 1, 3, negative 10, negative 1, negative 1. That's as simple as adding and subtracting is. We're going with multiplication by a scalar. So we're going to multiply by a scalar. Okay, this is just a number in front of our matrix. So this would be like 3 times the matrix, 2, 1, negative 3, 5. In order to multiply by a scalar, we're just going to multiply that number to all of the elements inside. It just distributes to everything inside. So 3 times this matrix would be 6, 3, negative 9, 15. And that would be your answer. Oftentimes when we do problems like these, we'll set up some matrices. So we'll say matrix A is 2, 1, 0, 3. Matrix B is negative 1, 2, negative 3, 0. And then from there, we'll do some operations. So we might say 3A plus B. So we know since we're doing addition, they have to be the same dimensions, which they're both 2 by 2. So we'd say 3 times matrix A. So I'm going to multiply everything in matrix A times 3, which would be 6, 3, 0, 9. And then to that, we're going to add matrix B, which is -1, 2, -3, 0. So now we'll add their corresponding elements. 6 plus -1 is 5. 3 plus 2 is 5. 0 plus -3 is -3. 9 plus 0 is 9. And that would give me my answer. The last thing we're going to do is determinant. A determinant is a number, a real number associated with a matrix. We'll quickly look at how to find a determinant by hand on a 2 by 2 matrix. So to find the determinant of matrix A, B, C, D, we would do the following. So the determinant of matrix A, B, C, D is equal to AD, so A times D, if you notice that's the diagonal, minus B times C. So we'd multiply our diagonals and then find the difference between them. So the determinant of A, B, C, D is AD minus BC. So you'll see a determinant written as DET with your matrix. You can also see a determinant written as your capital letter with what looks like absolute value bars around it. So if something told us that we had matrix A is equal to 2, 3, 1, -2, and then our question said, if question 1 said find or evaluate, it would probably say evaluate A with bars around it. That means evaluate the determinant of A. So you would do exactly what it says. You would find the determinant of 2, 3, 1, -2, which would be 2 times -2 minus 3 times 1, which we know to be -4 minus 3, which is -7. -7 would be your answer. When you're finding a determinant, the number is your answer. A 3 by 3 matrix determinant goes through a lot of different steps. It's actually a bunch of different diagonals written over. We'll be doing those in the calculator. In order to do determinants in the calculator, we'll go into the matrix menu once you've got your matrix typed in and find it that way. We'll talk about how to do that in class when I can show you step by step how to do that. So I just wanted you to see what a determinant is before you come to class tomorrow.